So we're going to start solving some trig equations here. We're going to keep it pretty basic in this particular unit. We're going to be doing 3 trigonometry units, right? This is our first one. So we'll talk about solving some basic ones today, but in the third one we're going to talk about solving more complicated types of trig equations. So today is just a kind of intro to the whole topic. You're going to probably want your unit circles, so if you don't have those out, you might want to get those out today. Let's begin here. So example 1. Yeah, I think we go up to 12 or 13. Okay, so this is a trig equation where we have to solve for the when I say solve a trig equation, that means we want to find out what angle is the answer, right? So in other words, sine of what angle is negative radical 2 over 2? Okay. So the first thing that you might want to keep in mind is sine is a y value, right? And this is the y value coordinate. On our unit circle. Okay? So it's a y value because it's a sine. Okay, now if it was cosine, it would be an x value, right? So this is if this is the y value coordinate, what we want to do is we want to think of our unit circle here, and you guys can look at it. And I want you guys to look around your unit circle and find what angle has a y value coordinate of negative radical 2 over 2, and what's the answer? Go ahead, Nick. What do you got?
Well, there's actually 2 of them.
There are actually 2 of them. Go ahead.
225.
225.
315.
And 315. So do you guys see that on your unit circle where at those angles the y coordinate is negative radical 2 over 2? That's for degrees. On your homework, some questions will ask for degrees and some will ask for radians, so I'm just going to do both for today. It's really not that big of a difference, honestly. You just say the radians. So looking at your unit circle once again, what are the radians at that point? 5 pi over 4. And what else? There you go. So some questions I want you to solve it as the radians. Some will want you to solve it as the degrees. But basically, we're just kind of interpreting a sentence here, you know. This, if you wanted to translate this expression here in English, it's just basically saying what angle gives a y value of negative radical 2 over 2. Okay? So that's kind of how you can interpret it. What angle gives a y value of negative radical 2 over 2? And at that point, you just look on your unit circle and get the answer. Let's do another one here. Cosine of theta equals negative 1. So for this one, how would I translate this into English? What angle gives me a x value of negative 1? So what angle gives me an x value of negative 1? I'll let you guys search your circles there. And what's the answer? Or? No, there's actually only one answer for this one. Pi, right? So, depending on whether you want degrees or radians, there you go. Now, some of them have two answers and some have one answer, okay? All the ones that have one answer to them will be the ones that are on the y-axis or the x-axis. All the ones that are in the quadrants, those will usually have two answers to them, okay? So, if I'm going too fast, just tell me to slow down. I can. All right, let's look at another one here. So this is different because tangent is not x or y, right? Tangent is a fraction of x and y, right? But the good news is we have a tangent circle, okay? So how I would translate this is what angle has a tangent value of that? So and you guys can look at your tangent unit circle to answer that. You can give me one, I'll let Amanda give you the other. Go ahead. What do you got?
330.
Which one? 330? Amanda, what's the other one? 150. And then we want to also be able to give the radian values. So for 330, I believe that would be 11 pi over 6, right? Notice I did that without looking at my unit circle. I would like you guys to be able to do that too. 150, okay, that's that one over there, slightly above the x-axis. When tangent's there, it's okay. That's 5 pi over 6, right? There you go. So you guys need to be able to visualize. Not there yet. That's okay. We'll keep working on it. But there you go. There's your two answers. Because like in calculus, for those of you guys that are moving on into calculus next year, you know, if you can't do that quickly, it becomes very frustrating and difficult for you to. You're not going to be able to bust out your unit circle every second, right? So you want to be able to see it, and that's why I keep quizzing you guys every day and all that stuff. I want to make sure it's locked in your brains. All right, let's do another one here. So sine, we're looking for a what value? A y value. For cosine, we're looking for a x value, and for tangent, we look at the. You just look at the tangent circle I made for you guys. Just look at the tangent circle I gave you. Okay? So for tangent, you're not looking for x or y. You're just looking at the tangent circle. Okay? All right. So there's your basic idea there. I'm going to throw a couple other things here at you before I let you guys practice a couple, though. How about this? I'm going to give you guys a couple of tangent of theta. It is undefined. Now, I don't know. This problem won't even come up on a question, but that's actually going to be helpful for our next unit if you can tell me where tangent is undefined. So where is tangent undefined at? At 0? I don't think so. At 90 degrees. And at 270. Good. Oops, I put 260 though. Which in radians would be pi over 2. Good. And 3 pi over 2. Okay? So why? Now that's going to come in handy when we get to graphing, because when you try to graph a tangent, because tangent actually has a graph, okay? Because it has an input and output, which is like an x and a y. You can graph those and turn it into a picture, right? Well, at that point it's undefined, and that's because it has a vertical asymptote at those points. It can't reach those values. It can get closer and closer to them, but it can't actually reach the 90 degree mark or the 270 degree mark, because at that point tangent's undefined. Last situation I want to share with you before I set you guys loose would be this. sine of theta is equal to 2 radical 3 over 3. Okay, so when I'm looking at sine, we're looking for a what value? A y value. Do you guys see a y value of 2 radical 3 over 3? No, it's not there. Okay. That doesn't mean there's not an answer, just so you guys know. But it does for today. and here's why. Because today we're only doing angles on the unit circle. So if you don't see that on one of your options, then just say no solution. Okay? But I'm going to give you a better answer because I want you guys to be able to think beyond just today. There's a reason this actually has no answer. If you guys do 2 times the square root of 3 over 3, I'll do it really quick. 2 times the square root of 3 over 3. That actually equals this. Now, you may not see the big deal with this, but I'll tell you what the big deal is. So the sine equals this, right? I'm going to draw you a picture. You don't have to draw this. You can just kind of pay attention for now. Now in the unit circle, when we have these little right triangles inside, the hypotenuse is always what? 1. And this represents my y value, this represents my x value, right? Okay, so we know the hypotenuse is 1. What else do we know about the hypotenuse on a right triangle? It's always the what? Yeah? It's the biggest side. So let me ask you, is it possible for y, which is sine, is it possible for that to equal this? No. It can't be bigger than 1. But that only applies to sine and cosine. Because sine is y and cosine is x. So this one and this one cannot be bigger than 1. But tangent can be bigger than 1. That's different. It's a fraction. And that's possible that could turn out to be bigger than 1. Cosecant can be bigger than 1. Secant can be bigger than 1. But cosine and sine can never be bigger than 1. So I'll write that down for you here. Cosine and sine cannot be bigger than 1. Now, for today, I would definitely write that note down and point a little arrow at that. For today, like I said, if you don't see it on your circle, well, then that's kind of your answer. It's no solution. But, you know, there are going to be, like, I could give you other things. Like, for instance, I could give you this, square root of 2 over 4. Well, that's not bigger than 1. So that actually does have an answer. Sine can equal this value. So there's a y value that goes with this. But it's not on our unit circle because it's not one of our special angles. And we will be doing a lesson where we start talking about how to find angles for non-special points on the unit circle. So the better way to think about it is just know that sine and cosine are not allowed to be bigger than 1. That's the best way to think about it, okay? All right, so I'm going to throw some student practices here at you. Let you guys mess around with a couple of these. But we learned a couple of things, you know. So first of all, sine is the y value, cosine is the x value. For tangent, you look at your tangent circle. The other thing that we saw was sometimes you get 2 answers, sometimes you get 1 answer. And we saw also that sine and cosine are not allowed to be bigger than 1. Okay? So I'm going to go ahead and throw a practice set at you here and let you guys go to town with it. You can do as many as you like in the time provided here. And I would encourage you to go ahead and put the radians and degrees. I think that's probably good enough for now. See how you guys do with that. There you guys go. You would like it to be, wouldn't you? But no, we've got a little bit more. We're going to, so you'll notice that we didn't do something. What didn't we do? The weird ones, right? So we're going to do the weird ones now, the reciprocal ones. And the only reason why we have to do that is because there's one extra or two extra steps you have to go through in order to answer the question. But here's how we're going to do it. Basically, we're going to turn them back into those three. Okay, so let's begin here. So we have, let's start off with something kind of, we'll start simple here. Let's do cosecants. This is example 2. I'm not going to write the directions, it's the same. We just want to find the angles. So use black here. Cosecant of theta is equal to the square root of 2. Okay. So cosecant is 1 over y, isn't it? You guys agree with that? Now what I'm going to do is I'm going to take the reciprocal of both sides. So what's the reciprocal of 1 over y? Good. And I'm just going to write y. But yeah, you're right. Y over 1. And what's the reciprocal of that? It's just this, right? Now, I think you're moving in the right direction. You already know what it's going to be probably. But if we flip that over, because this is over 1, right? So if you flip it over, you get that. Yeah, so basically if you just flip both of these over, well, whatever you do to one side of the equation, you have to do the other, right? So if I flip this side over, I've got to flip the other side over also. Otherwise, it's not the same anymore. Okay, so step 1, let's remember cosecant is 1 over y, right? We're going to flip that over. And so now we have this. But we're still not happy. Why are we not happy? We don't like radicals on the bottom. So we're going to do that. And what's that going to give me? So y equals radical 2 over 2. Now, we're looking for what? Yeah. What angle has a y value of radical 2 over 2? 45 and 135? I agree with you. All right, I had to think about that one. All right, so or we could say in radians pi over 4 and 5 pi over 4. Okay, so we have to kind of flip them over, if you will. Do another one here. Number 2. Secant of theta equals 2. Secant of theta equals 2. All right. So what is secant? So on the last problem, cosecant was 1 over y, so secant will be 1 over x, right? And then what we're going to do is we're going to take the reciprocal of both sides. So what am I going to write now? Yes. And so what angle has an x value of a half? Good. 60 and another one. 300. I agree. And then the radians for that would be pi over 3 and 5 pi over 3. All right, number 3. How about cosecant of theta equals 1/2? So what is cosecant again? 1 over y. And then we're going to take the reciprocal. Y equals 2. So what angle on your unit circle has a y value of 2? There isn't one, right? That's no solution. The y value and the x value, the sine and the cosine, can never be greater than 1. So the y and the x value can't be bigger than 1 because the sine and cosine can't be bigger than 1. All right. Let's do another one here. Secant. We'll get there. Secant of theta is undefined. Secant of theta is undefined. This is a weird one. Where is secant of theta undefined? Well, first of all, what is secant again? 1 over x. Now, I'm going to turn undefined into a number. Does anybody think they know what number I might turn that into? Kind of. 1 over 0. Because that's undefined. Any number over 0 is undefined. And I'm just going to use 1. You could use 2 if you want to, but it doesn't matter. But that's undefined, right? But if we flip it over, we're looking for where does x equal 0. Now, does that exist? It does, right? There is a place on your unit circle where x equals 0. Where is that at? Okay, so where is secant undefined then? It's undefined when x equals 0, and x equals 0 at 90 and 270. Or you could say, so that's an interesting question. I see why you're having struggle there. So secant is undefined when x equals 0. But x can equal 0, right? It's right there in our unit circle. There's a place where x equals 0, but that makes this function undefined. So what we're answering here, Zanab, is where is that function? Where does that function not exist? And that function does not exist at these values. Okay, yeah, there's a relationship there for sure. Yeah. The only reason why I'm showing my work is so you guys kind of can follow my thought process and understand what's happening. But I mean, I would like you guys to be able to do it in your head without even looking at your unit circle. But that's a dream. It's my math dream. All right. Let's do another one here. So let's recap though. So I'm going to change cosecant into what? When we see cosecant, we change it into what? Kind of. We change it into 1 over y, right? And then we take the reciprocal. When I see secant, what do we change it into? 1 over x, and then we take the reciprocal, right? And we also see that when something's undefined, we're going to replace undefined with what? 1 over. When I see something's undefined, I replace it with 1 over 0. And then when you take the reciprocal, now you got a voila, an answer that actually is there, right? All right. Let's go ahead and take a look at the next one. We haven't talked about cotangent yet. Cotangent. Cotangent of theta equals radical 3. Cotangent of theta equals radical 3. All right. So I changed cosecant into 1 over y. I changed secant into 1 over x. What am I going to change cotangent into? And I'll give you a hint.
Is it both?
It's not x or y.
Is it 1 over 10?
Yes. So I'm going to change it, because isn't cotangent the reciprocal of tangent?
Yeah.
Okay, so I'm going to change this into cotangent is the reciprocal of tangent, right? So just replace that. Since cotangent is the reciprocal of tangent, we write that. Okay? It's substitution. Here's another way to think about it. Cotangent equals 1 over tangent theta, right? Because cotangent is the reciprocal of tangent. So since cotangent is the reciprocal of tangent, I can replace cotangent with the reciprocal of tangent. Does that make sense? Okay. Now, what do you think I'm going to do? Flip it over. If I flip over this side, what do I get? I just get tangent. What does this side become? Yeah. There you go. That's good? Weird stuff. There it is. All right, and we're not happy because no radicals are supposed to be on the bottom. So we're asking now, where is tangent equal to radical 3 over 3? I'll take that, and then the radians for that would be these. Right? Am I wrong? Is it 7 pi over 6? You're right. You are right. Thank you. All right. So, I'm going to change cosecant into what?
1 over x.
1 over y. I'm going to change secant into what? 1 over x. And I'm going to change cotangent into what? I'm going to change cotangent into what? 1 over tangent, right? Okay. And then after that, you just take the reciprocals and do what you got to do. Let's do one more problem, then I'll set you guys loose on some. What number am I on?
6.
All right. Thank you. So let's say this. Where is cotangent of theta equal to 0? Where is cotangent of theta equal to 0? So, what do I change cotangent into?
1 over 10.
1 over tan. Now think of this as a fraction, right?
Yeah.
What? So if we take the reciprocal, what do we get? 1 over 0, which is undefined, right? If you flip over 0, you get undefined. So we're asking, where is tangent theta undefined? And on your unit circle, where does that happen? On your tangent circle, I should say, where does that happen?
90 and 2.
Okay, so, oops. So pi over 2 and 3 pi over 2. All right, so I think that kind of covers all of our bases there.